Good afternoon, everyone, and welcome to Layer by Layer, the Slant 3D podcast about the 3D printing industry and our place inside of it. Today, we're going to be talking about Formlabs and Markforged, some updates to Etsy and Tangled, and some new projects we have coming down. But let's go ahead and get started with the news. So there's a rumor going around, a wish, a dream. A couple articles, a couple of op-eds, that kind of thing. That have requested and theorized about Markforged being acquired / merging with Formlabs. This is an interesting idea. Actually, even this was promoted a little bit by Greg Mark, who was one of the original founders of Markforged, and I think he's still the chairman, or he's still on the board. I assume. I think I'm not. Don't quote me on that. But he had mentioned it on LinkedIn. And it makes sense. It makes sense on the surface of it. Like, okay, yes, Markforged is right now trading at about $150 million valuation. They've certainly taken a hit since 2020, like everybody else in the 3D printing industry has. And it wouldn't be unreasonable to say that maybe they've kind of peaked. I don't think so. Markforged has exceptionally good machines. But and they have a very good business model, quite frankly. I would say that Markforged is probably I'm trying to be more careful about some of this stuff because I'm technically working in the industry as well. I'm not really a journalist. I'm the CEO of another company. But Markforged is a very well-run organization. I really respect what they're doing over there. And the things they've done, both with the machines and everything else. I think they improved and got to the pinnacle in an obvious engineering way, in a very clean and good way when they did it. And I think they can do a lot more than what they've done so far. I think they can, beyond even just machine sales. But the focus of the company has been great because they haven't gotten distracted by a lot of other technologies. And this is kind of why I almost think that it wouldn't happen. Because yes, Formlabs is also a pretty well company, but Formlabs is going into 3D printing the way most of the companies do, which is acquiring a bunch of other technologies or building a bunch of other technologies and adding them to the catalog so they can sell more machines. But what that occurs is that you end up diluting your core competencies of like, okay, we have SLS and we have resin and we have FDM. But you're not the best at any of them. And quite frankly, it's really tough to be the best at any of them right now. There's 1,000 3D printer manufacturers out there. But the Formlabs is going that direction, so it makes sense that they would want to potentially acquire Markforged. It doesn't make sense for Markforged to be acquired because Markforged has been exceptionally focused about we make FDM engineering part-making machines. They're very good at that. And they're very good at that. And to then be absorbed into this growing conglomerate, that's not fair to Formlabs. That's really not fair to Formlabs because Formlabs has their own thing. But it'd be kind of an odd couple marriage while at the same time making sense because they're both Boston companies. Heck, probably half the founders went to school together. Most of them, I think everybody who founded both those companies are MIT grads. So it would be interesting. There's a lot of synergy present there, but it'd still also be kind of odd. And I think it would sell Markforged a little bit short because Markforged is an organization that has a long way to run. It's also to kind of back this up. ARK Investments has invested in Markforged. ARK Investment is Kathy, what's her name? She's a big Tesla bull. Kathy Green? No, it's not Kathy Green. I'm not sure. Kathy, her. She runs ARK, and they're a future technology kind of investment company. So they're heavy in Tesla, they're heavy in biomedical, and they pursued 3D printing. And they have a more than 10% stake in Markforged that they re-upped this year. So they see potential there, and I think it's for many of the same reasons as far as the growth of 3D printing that you would expect to see with Markforged. It's a very focused company, has had great growth. Yes, they're getting beat up in the public markets, but all the 3D printing companies are getting beat up in the public markets. There are a few companies currently publicly traded. While many of them are still unprofitable, including Markforged, They are in a position to where they could do more, or could hit profitability if they wanted to go that direction, but they've been in a growth mindset. But they're now not being rewarded for that in stock. So it's an interesting dynamic because a few 3D printing companies do appear to be undervalued just from assets held. But anyway, it's an interesting thing, and it'd be a lot of fun. General news: E3D's ObXidian nozzles are coming to Bambu Labs. This is interesting. This is one of the first kind of major consumer printer collaborations that I've seen. Bambu Labs kept almost everything pretty internal, but this is a very interesting thing to partner with E3D to have E3D's nozzles put on Bambu Labs machines. That is not something I really anticipated or would consider expected. The Bambu Labs seem to be doing a lot of their stuff internally. They don't use a lot of third parties, but to now open up the ecosystem, so to speak, is interesting. And I'd be fascinated to know what the trade was. E3D definitely has a very good brand, and Bambu Labs definitely has a very good brand. But E3D's competitive advantage is sometimes a little bit unclear. Because they're very good at engineering nozzles and systems and that kind of stuff. But there's a number of people who are pretty good at engineering nozzles and systems and that kind of stuff. So I don't know what they're contributing to Bambu Lab that Bambu Lab couldn't necessarily do itself. It's just, again, kind of an interesting dynamic, and it'd be cool to be behind the scenes. But it's great for the industry as a whole and everybody who wants to upgrade their Bambu Labs machines with the ObXidian nozzles. They're a really cool system and neat piece of engineering. The Peopoly Magneto has been delayed by 2 weeks. This is actually going to be about a week old by the time y'all get this podcast. But the Peopoly Magneto is the linear motor printer that came out a few months ago and was taking pre-orders, and they're shipping it now. It's a nifty system, and the fact that they got it down to as affordable as they did is a big deal because linear motors are flippin' spendy. But printers are a really good way to kind of introduce that type of technology because there is a decent amount of volume in printers. So they have the scale in order to reduce the cost of these otherwise pretty expensive components. Linear motors are a great way of doing it because, like they say, you get rid of the belts, you get rid of the gears and the interface, you just have a rail and the motor running along the rail. Fundamentally, it has a higher cost per unit than anything else, but that's okay. Supposedly, the delay was because the chips were having a weird bug that was causing some weird vibration or print artifacts. So they just wanted to clean that up, and they're expecting to have them going out middle of December. So there's all of that. Okay, Slant 3D stuff. So notification, a few weeks ago, months ago, we started doing like the testing videos of crushing and compressive strength of different infills and different materials and that kind of thing. There's going to be more of those coming. But we kind of put out the call of we wanted to formalize this a little bit because right now we use a strain gauge and a standard benchtop press to do the testing, which is a little bit inconsistent. And quite frankly, we'd like more formalized engineering data from it. And we think it's necessary in order to really start building up a data repository of all this stuff. So we want to get in a formal tensile and compression testing machine. But if we're going to be sharing all of this data that we're going to put a lot of work into creating, formatting, and structuring well, and then we're going to share it, we'd like to have a little bit of help with that. So we will be releasing a Kickstarter that will effectively be funding 20 videos based off of these testing machines. And we will post those videos, and for the cost of a spool of filament, you will be able to help us buy this machine. That all being said, excuse me. So yeah, that will be coming down here in about a week or so. Let us know if there's any like stretch goal tests that you want us to do. We have built into the campaign stretch goals. So like the baseline cost, the most expensive machine is the tensile tester. But once that's set, we want to go into UV testing, flammability testing, impact testing, and there's one other one. I'm losing my mind right now. But a bunch of tests. that we will be using as stretch goals. So once the core machine is purchased, the next stretch goal will activate the next machine, and then the next machine, and then the next machine, so that we can put together a lab for qualifying filament. Because this really, really needs done. Right now, there is no qualification of either printed parts or of 3D printing filament. And we've talked about this in the past, that like PLA Plus is BS and that kind of thing. It's not BS for everyone, but there is no way of knowing who it actually is telling the truth or who isn't. PLA Plus can be just, oh, this is pretty good regular PLA, or PLA Plus can be a different material that prints differently and behaves differently. So the identification of brand name from engineering spec needs to be done, but there's no third-party testing person to do that or organization to do that. So we want to get that built, and we want to start building a 3D printing qualification lab where we will qualify materials, verify materials, get the data on the materials, but then also qualify those materials in a printed state. So print off all the dog bones and the different orientations to say, okay, this material printed with this settings in this situation has this much interlayer adhesion strength and that kind of thing. So that there is a actual data set, a MATLAB data set that says, okay, 3D printed Z-axis orientation strength. There it is. So that people can actually do engineering around these materials. We have obviously a big interest in having that done. So, but in order to share all of that information and produce all the videos and make sure that it's formatted and available to y'all, rather than us just storing it in a spreadsheet internally, we'd like to have some help with the machine because they're expensive machines. So if you guys can all just be on the lookout for that, it'll be coming down. We will do a separate video where we go into the details of it a little bit more, but it's coming down, and it's something really necessary. The testing lab is something that just needs done for the industry, because right now nobody's held accountable and there's no objective standard for how this stuff is. There's a bunch of kind of shared knowledge and rule of thumb things. But for 3D printing to continue to scale up and to be used in more products and materials, a better data set and engineering chart is necessary. And we can start kind of putting together that chart. And it improves hobby materials a lot too, because you know what you're getting. And you know that, oh, when they add yellow dye to it, it gets weaker than when they add black dye to it and that kind of stuff. And, oh, it got more elastic, or the TPU doesn't hold up under UV light because now it's dyed black rather than clear, and so on and so forth. All of those things are tests that we can do that make sure that your parts do what they need to do. And you can pick the material that will do it for you off of very objective information. So, yeah, the testing lab Kickstarter will be coming down here very soon. Keep an eye out for that. API will be released here very soon. The API has been performing very, very well in the beta testing that we've done, and we want to get it turned loose for people to use. We were expecting about mid-December to turn it loose. It might push into January just for the sake of not releasing the week before Christmas when everybody doesn't really care. So yeah, we're working on that. So the API will be coming out very soon. With the API, we will be releasing it with a demo app. Basically, we're going to open source our entire print-on-demand prototype app. So that anybody, if you're a college kid or a developer or any of it, you have a full example application. It's built on Next.js, so it'll be serverless and just stupidly quick and easy to build and put up. So hopefully you can take that print-on-demand app that is able to accept a file and send it to our API, and then build a customer and that kind of stuff. Has the fundamental functionality to where you can build an app that actually can run on the API. So maybe a nightlight maker or a cookie pot maker, or just collect a bunch of STLs and have your own little print-on-demand store or something like that. All of those are feasible. And there will be an example application to show how to do that. We're going to try to get as much documentation around that as possible. Obviously, the API will have its base documentation, but around the app itself. We're working on trying to get a video together of the full build process of the app too. We'll see where that is as far as time of the team and that kind of thing. But the API will be really sweet. And yeah, should be able to come out. We've got a few bugs to work out on it, but it's almost there. The Etsy app. The Etsy app is functioning, and we're taking care of folks. We're going to pause new users for a bit because right now the usage is starting to break some of our servers. So we are going to restrict new users here for a bit until we get through the Christmas season, and then we will open it back up for new signups and hopefully have an update. We're working on getting it upgraded here in the moment to make sure that we're taking care of everybody who's using it. So we're doing that. Let us know if you're running into any bugs on it and that kind of stuff, because we need the feedback. We can't always see what the errors are, and the team is working as fast to squash those bugs as quick as we can. You guys would be amazed how much stuff can break. Somebody opens it up in an incognito window on Safari or whatever the heck their incognito is, and it changes how the app plays out or something like that. And yeah, all the things. So we're also taking the feedback on the new features, and we're working to get the new features added in to improve the overall functionality of it. Right now it is quite basic, but that was the point, to get to a core product that you guys can rely on to make a piece. So the Etsy app is being refined right now, but yeah, we're going to just pause new signups here for a bit. And I think the guys may be sorting out inactive stores too. Yeah. Okay. Let's see here. What else is up? Torsion tester. The torsion tester was the other machine for the testing lab. The main machines that we want are the tensile and compression tester, which if you've ever seen them, pulls it, squashes it until the thing breaks. Those are a very common test for material properties, and we want to apply that to 3D printing. The next stretch goal will be the UV tester, because UV is something that people really care about, and right now the information out there is just garbage about how materials behave to UV. Really, really bad. Like, people overestimate how damaging UV can be. UV is not good, but they go for many people reach out for like UV resistant stuff, and UV resistant very often is not as necessary as people believe, because UV resistance is kind of like fire resistance. And bear with me with this analogy. As the sun hits up, if you've got a solid block of plastic, okay, sun hits the outside, it will slowly start to fade. UV resistance almost always leads with color degradation, because that's the thing that just gets beat up by the UV. But then there is secondary mechanical degradation from UV from just hitting plastics that causes them to decay. The difference is that most of the time, the reason UV degradation has been an issue is because you have a thin-walled plastic that's been molded. And that thin-walled plastic, the UV penetration is deep enough to where it can cause degradation of the mechanical properties of the part as a whole. However, as UV hits a part and it fades out and continues to go deeper, UV can only penetrate through a certain depth of the surface, depending on what the material is. So after it's burned the exterior of the part, that exterior is almost kind of like ash. Yes, it's no longer structurally sound and it looks faded white, but now it acts as an insulator and it blocks UV from hitting the more material underneath. 3D printing is able to have structural material underneath because you can make really thick parts. So you can make a PLA part that will sit out in direct sunlight forever. Now, that from a UV perspective, PLA you don't want out for thermal regulation and all the rest of this kind of stuff, but it can be UV resistant. And you can use lower grade plastics like PETG, which are not explicitly UV resistant, for functional parts as well, so long as you don't care about the color change. And the color change is very often a big issue. But people often say, oh, you need UV resistance, you got to go all the way up to ASA. But that jacks up cost and that kind of thing to where you don't really want to do that. So we want to get good information out there about UV resistance of plastics by the reason the tensile tester is the first machine that we get, because we want to know strength. That's the ultimate test of the part. No strength. But then if you put a part into UV and let it sit in the sun for 5 years, how strong is it then? And then let it sit for 1 year, and how strong is it then? And let it sit for 100 years, and how strong is it then? So the UV tester is the follow-on to where we can see degradation from sunlight over time and test those parts. So one of those tests would be like literally you put 10 parts inside of the UV machine, you let it crank it up to speed so that it tests every 5 years, and you pull off a part every 5 years, and you get a lifetime test of a piece in sunlight. So that UV tester will be really sick. Then we will do a flammability tester because UL rating for flame proof needs to be verified. And again, knowing the flammability of particular materials from particular suppliers is very useful. This is also very useful to us around engineering of the parts. And then a drop tester. Drop tester, heavyweight, falls down on top of the thing. This is, I would say it's a reasonably unscientific test because the machine that we're looking at is actually for testing helmets, but we want to test helmets and we want to test impact on shoe soles and that kind of thing. And this machine can qualify those things. So there's a lot of interesting tests that can come from that. And then the final one is a torsion tester. The torsion tester is interesting because it helps induce fatigue inside a layer line. So if you print a part flat like this, then you put it in the torsion tester and start twisting, you're able to induce the shear forces across the layer lines rather than direct tensile forces across the shear lines. And it's a really good way of testing fatigue. By the way, the tensile tester can also do fatigue testing. So we'll just have basically a little flap here that it pushes up and down on until it breaks. And we can do lifetime fatigue tests of PLA, PETG, and different layer heights and all that kind of stuff. So this is a deeply useful thing for the entire industry to know how this is done because nobody is doing it, except occasionally an undergrad will 3D print a dog bone in 3 orientations and release a paper from that. And those are fine 10 years ago, but we need to just build up a huge amount of data. We need the 10 variations of everything all the way through. And then again, like I say, the qualification of print testings or print settings is so important. Layer height, how does it affect strength? How does it affect waterproofness? How does it affect UV resistance? And then torsion tester and so on and so forth. Because like interlayer adhesion, really interesting dynamic with interlayer adhesion is the fact that having more layers can be good, it can be bad. I know there's a number of testing videos out there, but there is a lot of context around interlayer adhesion based on the material, based on settings themselves, based on the actual force situation, force setup. So we'd love to expand on that more to make sure that it's very comprehensive. That's what we're going for, is a comprehensive engineering data set to where you can say, my part needs to stand up to this much strength. Well, what is a material that fits on that? You run down the chart and you're like, right there, this material from this brand holds up this well. And it's the one to use. And it's been qualified by formal lab testing equipment with a formal process, matching standard ASM or ASTM standards and that kind of thing, which we will do. So that's that, guys. I'm going to go ahead and cut it right there. Do comment below other topics that you want us to see. Do also, in the context of the testing machine, tell us other tests that you would like to see at some point in the future, because we're gonna try to get this done as hard as we can, and that Kickstarter will be coming up here in a couple weeks. And again, like I say, for the cost of a spool of filament. But no, we would like to get a lot of help on that because we do want to get this information out there. But sharing it is easier to justify when all of you have contributed to it. And then long term, we might turn it into like a Patreon to where we can have ongoing tests and you guys can request specific tests. And we can hold these filament manufacturers accountable and get a good comprehensive engineering data set of like, this is true, this is not, this is good, this is bad, from a very quantitative standpoint. Alrighty, thanks a lot, everybody. Have a great day and see you later.